I'm Anil Kumar, sharing with you a test question on polynomial functions, which will help you to review the characteristics of such functions. The question here is, given a polynomial function f of x of positive even degree, decide whether each of the following statement is true or false. A. F of x is an even function. B. F of x will have at least one zero. C. F of x will have at least one turning point. D. Graph of the function will extend from quadrant 2 to quadrant 1. You can pause the video, answer the question, and then look into my suggestions. Okay, now let's begin with understanding the question first. We are given a polynomial function of positive even degree. That means n could be equal to 2, 4, 6 and so on, correct? That's the degree of your polynomial. Now it says f of x is an even function. Well, even function means that f of minus x should be equal to f of x. Is that okay? Also, it means it is symmetric about y-axis. Is that okay? Now, will all of them be symmetric about y-axis if the degree is even? The answer is no, and therefore the statement is false, right? Example, can you give me one? Well, a simple example could be f of x equals to x minus 1 whole square, right? Let's sketch this function. F of x equals to x minus 1 whole square. X minus 1 means that the function has been translated one unit to the right. So it could be something like this. Clearly, this function is symmetric not about y, but at 1. Is it okay? So it is not symmetric about the y-axis. You could also prove that f of minus x is not equal to f of minus x is how much? It is equals to minus x minus 1 whole square, which is x plus 1 whole square, which is not equal to f of x. So both algebraically and graphically you could show that all even degree functions are not even functions, correct? Very important. The second one here is f of x will have at least one zero. Well, this statement is also false. Example could be f of x equals to x squared plus 1, for example, right? So if I have f of x equals to x squared plus 1, the graph would be lesser like this. Is it okay? There are no x-intercepts, right? C is f of x will have at least one turning point. Well, the end behavior is that both are on the same side and therefore they have to turn, and therefore this statement is always true. Yes, that is true. Part D is graph of a function will extend from quadrant 2 to quadrant 1. That means they will always extend from quadrant 2 to 1. Is that true or false? Well, this statement is true only if the leading coefficient is positive, right? However, if the leading coefficient is negative, then it is not true. Therefore, this is false. Example is f of x equals to minus x squared, for example. Is it okay? So if I have minus x squared, the graph will be kind of like this. Now this moves from which quadrant? It moves from quadrant 3 to 4, right? Not from 2 to 1, since the leading coefficient is negative. Is it okay? So that is how you could easily answer these questions. I'm Anil Kumar. You can always share and subscribe to my videos. Feel free to ask questions. Thank you and all the best.